Let's take some few examples for integrations of exponentials. Let's say e raised to x into e raised to x. Here x into e raised to x square, e raised to x upon e raised to 1 minus e raised to x. Okay, now here, how to integrate this type of, first of all, integration of e raised to x is, dx is e raised to x plus some constant c. Okay, this is the formula we have. Okay, if I put e raised to x instead of x, if I write like this, e raised to x dx, then what will come? Okay, this will be e raised to x into, okay, here into here upon a raised to, okay, here d by dx of x. E raised to x, integral of e raised to x dx is equals to e raised to x upon d by dx of whatever the indices of power of e, that is x plus c. Okay, that is e raised to x upon d by dx of x is what? Differentiating with respect to x will be a plus c. Okay, another we have, for example, if I have a raised to x, a is some constant greater than 0, a is some constant greater than 0, this type of integration will be a raised to x upon log of a. This is the formula. Okay, now let's see how to integrate this type of basic integrations of exponential. Okay, now the first one is integral of e raised to x into e raised to x raised to e raised to x. Okay, here in this type of integrations we need to put some parameter u. Okay, u substitution we call. Okay, now if integral of e raised to x into e raised to x dx. Okay, now if I put e raised to x as u, let's see what will come. Okay, if I put u is equals to e raised to x, then du upon dx will be e raised to x. Okay, now dx I can send that side, this become a dx. Okay, now if I put this term as a u, then I am getting e raised to x into dx as a du. Okay, so it has meaning. Therefore, integral of e raised to ax into dx is what? E raised to ax into dx is become a du. Okay, now here du. E raised to this term I already put as a u. Okay, here u. Let me repeat again. E raised to x, here this part I am already put u. This become a u, and e raised to x dx is become a du. Okay, now integration of this is e raised to u plus c here. Okay, if you stop here, then that will be a wrong answer. Okay, because u we don't know. Okay, you already substitute u, you have to come back into the variable x. Okay, therefore this will be what? E raised to, what is u? U is e raised to x. Okay, e raised to x plus c. This is the required answer. Okay, now let's take this example. Example number 2. Let's this 1, 2. Integral of x into e raised to x square dx. Here also you have to think. Okay, now if I substitute something, then for example if I substitute x square equals to u, then I will be getting what? If I differentiate x square, then du will be twice x into dx. Okay, so here I am getting x dx somewhere. Okay, so if I put u equals to x square, then du will be twice x into dx. Okay, now what I need? X into dx, so I can send these two down. Du upon 2 equals to x into dx. Okay. Now here, this is what? E raised to x square. It become a u. E raised to u x dx. X into dx is du upon 2. So I can write here 2. Okay. This is 1. Integral of e raised to u du is same as e raised to u plus c. Similarly, you cannot stop over here because we already put substitute u equals to x square. So you have to come back again. Is equals to half e raised to u, what is what? X square plus c. Okay. This is the correct answer. Okay. Now, in this sum also, okay. Now, if I substitute 1 minus e raised to x as a u, similarly, I will be getting du. Okay, let's put u equals to 1 minus e raised to x. Then du equals to minus e raised to x dx. Okay. Now, I need only e raised to x into dx. So, minus will send over here. Therefore, minus du will be e raised to x into dx. Okay. Now, this e raised to x into dx is comma minus du. This is minus du 1 upon 1 minus e raised to x is u. So I can send minus outside 1 by u du. Okay. In integration formula we have integral of 1 upon x dx is log of x plus c. It means if you are differentiating this, if you are getting this, okay, then that is log of numerator denominator. Okay. So that this formula you can use directly over here. That is minus log of u plus c. What is log u? U is minus log of 1 minus e raised to x plus c. This is the required answer. Okay. These are a few basic examples for differentiation integrations exponential. There are many examples for differential algebraic integrations of exponential. For example, integration of we have product rule. For example, e raised to ax. How to integrate e raised to ax into, for example, 5x dx. These are integrations we have to apply. Integration by parts. There are different examples we have. So in further lectures we'll be speaking about it.